Okay, let's set the scene. It's February 1943. Kazan Pass, Tunisia. German forces are pushing hard against, well, frankly, inexperienced American troops. But amidst all that chaos, the elite German tank commanders, these are the veterans of the Wehrmacht, they're witnessing something. Something that just doesn't add up. You've got choking dust, smoke everywhere from burning vehicles and gunfire, and through it all, American Sherman tanks, often way out of sight of each other. They're pulling off these maneuvers that look almost, well, supernatural. Think about it. 5 tanks, maybe separated by hills or dust clouds, converging perfectly on one target, each one covering the other's flanks, like they're all linked somehow.
Moving like a single organism, not just individual tanks. And the Germans, in their panzers, they just couldn't understand how.
Right. Their own Fuji 5 radios, the standard German sets, they were struggling with static. Just trying to hear the platoon leader a few hundred meters away was tough, especially with engine noise.
Exactly. Those were AM radios, amplitude modulation, state-of-the-art maybe in the 1930s, but incredibly vulnerable to electrical interference. Engine noise, track clatter, even the turret motor-generated static that could just wipe out the signal.
So the Germans are baffled. They're thinking maybe the Shermans have better armor, better engines, but the real advantage, it was totally invisible.
It was electromagnetic. It was the radio, specifically frequency modulation or FM technology.
An invisible edge that was arguably more decisive than the gun or the armor thickness.
Absolutely. This deep dive is all about that edge. It's about the, 181 pounds of equipment that created history's first real battlefield network inside those Shermans.
Okay, let's unpack this.
So the technological gap here it's really stark when you look closely. The German Fuji 5, as I said, AM, 10 watts of power, decent range on paper maybe, but in combat, hundreds of meters if you were lucky, especially when moving.
And the crucial point you mentioned earlier, not every tank could even transmit.
Precisely. Most German tanks only carried the Fuji 2 receiver. So maybe 1 or 2 tanks in a platoon of 5 had the full Fuji 5 transceiver. The rest could only listen.
Which forces that really rigid top-down command structure if the leader's tank gets hit.
The whole platoon basically goes silent, coordination collapses, they're back to visual signals flags, hand movements, which in the dust and smoke of battle, almost useless.
Okay, now contrast that with the American setup. They standardized their new radios pretty early, July 1941. The SCR 508 family sources mentioned the 508, 528, 538.
Right. Those designations basically refer to slightly different configurations of the same core system, tailored for different command roles like platoon tanks, company command tanks, etc. But the key thing, they were all built around FM technology.
Developed by Edwin Armstrong. And this FM tech, it just worked differently.
Completely differently. FM focuses on changes in frequency, not the signal's amplitude or strength. All that electrical noise that drowned out the German AM signals, FM inherently filters most of it out.
So clear voice communication.
Crystal clear, relatively speaking, even with the tank bouncing around, engine roaring, artillery landing nearby. Plus, they packed more power, 25 watts transmission power. That's 2.5 times the German output. Much better range and clarity.
And this wasn't some off-the-shelf tech. American engineers really had to work at this. Galvin Manufacturing, which we now know is Motorola.
Yeah, funny to think they were making car radios before the war.
Right. And suddenly they're building these sophisticated, ruggedized radio sets. You see names like Daniel E. Noble, who saw the potential, and Henryk Magnoski, the lead engineer.
They had to figure out how to make this relatively delicate electronic gear survive inside a vibrating, electrically noisy metal box that's getting shot at. It's a huge engineering challenge.
That 181 pounds of radio gear, it effectively turned every single Sherman into a command node on a network. A totally different way of fighting.
And you saw the impact almost immediately. Operation Torch, North Africa, late 42. That's the combat debut for these systems in large numbers.
And the difference was noticeable right away.
Yeah, absolutely. Because every American tank had a transceiver, the SCR 508 or 528. They could all talk and listen. If a platoon leader's tank got knocked out, any other tank commander could just take over communications instantly.
So redundancy versus that German rigidity.
Exactly. And then you get to Kazan Pass in February 43. Now, tactically, that was a tough battle for the Americans, a German win in many ways.
But strategically, it showed something new.
It did. You had scattered American units, elements of the 1st Armored Division, separated sometimes by 50 miles, but still coordinating, sharing warnings, calling in artillery strikes, all with this remarkably clear FM signal.
German signals intelligence pick up on this, didn't they? They noted the clarity and the range way beyond what their own sets could manage.
They did note it, but here's where it gets really interesting. Their analysis completely missed the mark.
How so? Why didn't they immediately think they have better radios or try to jam them?
Well, jamming FM effectively requires different techniques and equipment than jamming AM, which they might not have had readily available or understood the need for. But the bigger failure was interpretation. The German High Command reports attributed the American coordination to, and this is almost a direct quote from some analyses, extensive training and rigid communication procedures.
So they thought it was just discipline, not technology.
Pretty much. They failed to grasp the fundamental technological leap of FM over AM. They were stuck in their own paradigm, focusing on improving the tank itself, bigger guns, thicker armor, not the network that connected the tanks. A massive intelligence blind spot.
That focus on the platform over the network.
Wow. And that must have become even more critical in places like Italy.
Oh, Italy, September 43. Perfect example.
Yeah.
Mountains, valleys.
Mm-hmm.
That kind of terrain should wreck radio signals, right? Especially AM.
Yeah, signals bouncing everywhere, creating interference, dead spots. Exactly. Multipath interference. It crippled the German AM radios. But the American FM sets, they handled it much better. The nature of FM makes it less susceptible to that kind of signal reflection chaos.
So American tanks could coordinate attacks across ridges, even when they couldn't see each other at all.
Precisely. They could talk through the terrain in ways German doctrine, reliant on line of sight and limited radio, just couldn't match.
But it wasn't all smooth sailing. There was a big problem later on, wasn't there? Normandy, June 44. The Bocage country.
Yes, the hedgerows. A brutal environment for tanks, and it exposed a critical communication gap. Not within the tank units, but between tanks and infantry.
Different radios, different frequencies.
Exactly. The tank radios, the SCR 508 family, operated down around 20 to 28 megahertz. The main infantry backpack radio, the SCR 300 walkie-talkie, operated much higher, 40 to 48 megahertz.
Nope, they just couldn't talk to each other directly.
Nope. Completely incompatible bands. And in that close-in hedgerow fighting, where German infantry with Panzerfausts could sneak right up on a tank,
the nearby U.S. infantry couldn't quickly yell a warning over the radio to the buttoned-up tank crew. That's deadly.
it was a huge problem initially, but the solution they came up with, it's classic GI ingenuity.
The field telephone fix, right?
Yeah.
Tell us about that.
Pure brilliance, born of necessity. Tank crews started grabbing empty metal ammunition boxes,
Okay.
welding them onto the outside of the Sherman hull, usually near the back. Inside the box, they mounted a standard E8 field telephone.
A regular Army field phone.
Yep. And then they ran a wire from that external phone directly into the tank's internal intercom system, the BC-606,
So the infantry guys outside could literally just pick up the phone on the back of the tank.
and talk directly, clearly to the commander and crew inside, cutting through all the engine and battle noise. It bypassed the whole radio frequency problem.
That's amazing. A physical connection.
It revolutionized tank infantry cooperation almost overnight by late July 44. Suddenly, they could work together seamlessly in that close terrain. It was vital for the breakout.
And with that sorted, you really see the network power unleashed, right? Operation Cobra, the breakout from Normandy.
Oh, absolutely. Cobra, late July 44. You have the 2nd Armored Division coordinating, over 200 Shermans using these FM networks. The speed of response was just unprecedented.
Like calling in fire support.
Exactly. A tank crew spots a target, calls it in over the radio net. Artillery coordinates are relayed. Rounds are downrange, sometimes within minutes, 2-3 minutes maybe.
Compared to the Germans.
Their process, relying on runners, slower radio links, multiple command layers, it could take 15-30 minutes, often much longer, by which time the target has moved or the situation has completely changed.
Okay, let's talk about a specific battle that highlights this.
Yeah.
Aircourt, September 1944. This one seems almost unbelievable. American Shermans versus supposedly superior German Panther tanks.
It does sound incredible on the surface. The 4th Armored Division faced elements equipped with Panthers, which definitely had better armor and a more powerful gun than the Sherman's 75mm or even 76mm.
Yet the kill ratio was apparently staggering. Something like 7-1 in favor of the Americans.
The numbers cited are often around 281 German armored vehicles, including many Panthers and Panzer V, lost, versus about 41 Shermans from the 4th Armored. It's debated, but the disparity was huge.
So how? Was it just numbers? Air power.
Air power played a role in the campaign, yes, but in the specific engagements at Court, the key difference identified in most analyses was coordination and fire support. The numbers of tanks actually engaged were often comparable locally. The Shermans, using their SCR 508s, could maneuver rapidly as coordinated units, call in incredibly fast artillery support onto the German positions, and share target information instantly.
So even if a Panther was technically superior one-on-one.
It rarely was one-on-one. It was one Panther facing multiple Shermans that knew where it was, were coordinating their fire, and had artillery raining down around it, called in via radio just moments before. The network swarmed and overwhelmed the individual platform.
It really drives home the point. The network defeats the platform.
And the deep irony here, as you look through the history, involves Heinz Guderian,
the father of the Blitzkrieg. He demanded radios and tanks back in the 1920s and 30s.
He absolutely did. He understood fundamentally that communication was the key to mobile warfare. His whole doctrine was built on it.
Yet by 1943, German industry couldn't even meet his own standard.
It's quite tragic from his perspective. In 1943, Germany built something like 5,700 medium tanks. But they produced fewer than 2,000 of the Fudgy 5 transceivers needed to equip them properly. They were falling short of their own doctrine.
Meanwhile, in the U.S., Motorola cranks out how many?
Over 50,000 sets of the SCR 508 family radios during the war. 50,000.
Enough for every single Sherman built.
Pretty much. Over 49,000 Shermans were produced, and the radio production ensured virtually every single one rolled off the line with this advanced FM system fully installed and operational. A 100% deployment rate. Think about that compared to the Germans, or even the Soviets, whose T-34s often fought entirely without radios.
That industrial capacity difference is just staggering.
And beyond the sheer numbers, the details of the SCR 508 system really mattered in combat.
Like what specifically?
Okay, first, crystal stability. The American radios used quartz crystals to lock onto specific frequencies. You could preset your channels, maybe 10 options, and they stayed locked on, rock solid, despite vibration, temperature changes, whatever.
And the German radios.
They used older variable capacitor tuning, much more prone to drifting off frequency, especially under combat conditions. German crews constantly had to fiddle with the tuning dial to stay connected, assuming the connection even worked. Huge distraction under fire.
Okay, what else?
Second big advantage, dual receivers in many sets, like the SCR 528 used by commanders. This meant a tank commander could monitor his own platoon's radio net and the company a command net simultaneously.
So he's hearing his own tanks talk, plus orders coming down from higher up.
Exactly. Instant flow of information up and down the chain, massive situational awareness boost, the German commander usually just listening on one channel, if at all.
And third,
the internal intercom system, the BC606. Seamless communication for the entire crew. Everyone had throat microphones and noise-canceling headphones. The driver sees something, instantly tells the commander. Loader confirms up. Gunner confirms target. Constant internal chatter.
Compared to the German tanks.
Many lacked integrated intercoms entirely, especially earlier models or even later simplified ones. Crews might have to shout, bang on the turret wall, tap the commander on the shoulder. Impossible in the heat of battle.
All these small advantages add up, and it circles back to that intelligence failure. The Germans just kept missing it.
Consistently. Or they focused on trying to identify and knock out specific command tanks based on antenna setups.
Not realizing every Sherman was effectively a command tank because they could all transmit and coordinate.
Precisely. They were targeting nodes without understanding the power of the whole network.
And you have to think about the psychological impact. For the American crews, knowing you're connected, you can call for help, you can coordinate. That builds confidence.
Immense confidence. Whereas for the German crews, especially later in the war, fighting with unreliable radios, often unable to report threats or coordinate defense, that must have led to a feeling of profound isolation on the battlefield. It erodes morale terribly.
Did the Germans ever fully realize the extent of the gap?
Really only after the war. There's a U.S. Army Technical Intelligence Report, number 176, that concluded German tank comms gear was roughly 5 years behind the American systems. And maybe the most telling point, when the Soviets evaluated captured German equipment alongside Lend-Lease American gear, what did they choose to copy for their own post-war tanks?
Let me guess. The American designs.
They copied the American radio designs. They recognized the superiority of the FM systems.
So what's the big takeaway here? It really wasn't just about having more tanks or even necessarily better tanks in every single category?
No, it was about how those tanks worked together. There's that quote often attributed to Field Marshal Keitel at the surrender, maybe apocryphal, but it sums it up perfectly.
Which one is that?
We knew how to build better tanks, but you knew how to make them work together. Whether he said it exactly like that or not, the sentiment captures the truth revealed by the SCR-508. And the legacy of this is, well, it's fundamental to all modern military doctrine, especially armored warfare. That principle of network-centric operations. It arguably starts right there with the SCR-508 in the Sherman.
Information dominance becoming as important, or maybe even more important, than platform superiority.
Absolutely. Look at conflicts like the 1991 Gulf War. Same principle, just vastly more advanced technology. The ability to see, coordinate, and strike faster than the enemy enabled by the network proved decisive. The network defeats the platform. The SCR-508 was the proof of concept on a massive scale.
So in the end, the ability to coordinate, to share information instantly, to fight as one unified organism, that invisible advantage proved more powerful than high-velocity shells or thick steel armor.
It was invisible right up until the moment it became catastrophic for the opponent. It turned a good, solid medium tank, the M4 Sherman, into part of an absolutely devastating combined arms system.
And maybe the final thought for you to ponder, that German failure. The failure to recognize the communication gap, prioritizing bigger guns over better signals right until the end. It really stands as one of the great intelligence and doctrinal failures of the war.
A huge what if.
Yeah. Imagine if they had pivoted, focused on matching that FM technology back in '43 instead of just chasing heavier tanks. How different might those final battles have been? Something to think about maybe the next time you rely on getting a perfectly clear signal.